Hello, welcome to this video. We are going to talk about incorporating graph databases in your .NET applications using Amazon Neptune. My name is Anil Sharma, and I am a solution architect with AWS. Amazon Neptune is a fast, reliable, fully managed graph database service that makes it easy to build and run applications that work with highly connected datasets. The core of Amazon Neptune is a purpose-built high-performance graph database engine, optimized for storing billions of relationships and querying graph with low latency. Amazon Neptune supports popular graph models, property graph, and W3C's RDF, and their respective query languages, Apache Tinkerpop Gremlin and SparkQL, allowing you to easily build queries that navigate highly connected datasets. Amazon Neptune is a fully managed service. As a fully managed service, you can use and configure it easily via the console. You can enable high availability across multiple availability zones, provision read replicas to scale reads, and configure encryption at rest and in transit. Now, before we go any further, let's look at typical use cases where Neptune can be used. Neptune powers graph use cases such as recommendation engines, fraud detection, knowledge graphs, drug discovery, and network security. A lot of applications being built today need to understand and navigate relationships between highly connected data to enable these use cases. For example, if you are building a news feed in your app, you wanted to show updates that are most relevant, updates from their families, friends, and from the people that they like or from the user history. If you're building restaurant recommendation app, you want the app to provide restaurant recommendations that at least two of their user friends have liked. If you're building a retail fraud detection application, you want the application to easily detect relationship patterns, like multiple people sharing the same IP address but residing in different physical addresses. In all of these use cases, because the data is highly connected, it is easily represented as a graph, and you can use Amazon Neptune as well. Now let's talk about connecting to Amazon Neptune in our .NET applications. An Amazon Neptune database cluster can only be created in an Amazon Virtual Private Cloud or VPC. Its endpoints are accessible only within that VPC. So for the purposes of this demo, I set up an environment as shown in the diagram. I provisioned a Neptune cluster within a VPC. Within the same VPC, I also provisioned an EC2 instance from where I will run my .NET application to query the Neptune database. I'm using Visual Studio to build a console application. Now let's look at my Visual Studio application first. Before we look at this, let's look at what are the packages that we have. I'll go to Manage NuGet Packages. I go to the installed ones. As you can see, I have gremlin.net package installed. This is the package that I will use to connect and query my Neptune database. To connect to my Neptune database, I created an instance of Gremlin server using my endpoint. The endpoint is what I received when I provisioned my Neptune database cluster. Using the Gremlin server instance, I created a Gremlin client, which is what I will use to query my database. If I go to the next file, you will see this is how I use my Gremlin client to fire various kinds of queries. Right? Now, before I did, I provisioned a Neptune database cluster and populated it with sample data. The sample data that I used has some tweets and users who have made those tweets. It also has data about who has liked tweets from whom, who is following other users, retweets, mentions, etc. As you can imagine, it's a highly connected data set, a graph. Now let's see the code in action. Remember that the Neptune is accessible only within AWS VPC that it was created in. I will now go to the EC2 instance that I created in the same VPC. This is my EC2 instance. I already have the console application running. In this sample, we are querying Neptune database to find answers to 3 questions that we are asking of it. The first is, how many tweets has a user made? Let me select that option. It will ask me for a username or ID for which I want to find out the number of tweets that the user has made. I'll give it a user ID, let's say 5, and it will go ahead and tell me how many tweets has this user made. In this case, 6 tweets. The second question that I'm asking is, how many followers does the user have? Again, let me choose that option. And in this case, again, it will ask me for the user for which I want to see the number of followers. I give it a user ID, and it tells me that the number of followers for that user ID is 60. The third question that we are asking of this database is, how many followers are common to 2 specific users. All right. This is a typical question that you might ask of your graph database, where you want to find out the followers who are following both user A and B. Let's use that option. It'll ask me for this user 1. It'll ask me for the second user as well. And then it'll go ahead and tell me, traverse the graph and tell me that the number of common followers is 25. So that is how we connect and query our Neptune database. Now in today's example, I showed you how to connect to Amazon Neptune and how to query Neptune using .NET Framework. I hope you found that useful. Thank you for watching.